Everyone, thank you all so much for joining this session on securing your data with Azure Synapse Analytics. You heard from Ron. Ron and I are here to first let's start off with Azure Synapse Analytics. Really, what is it, and sort of how are we improving the security side of you developing your analytics solutions? Who here has heard of Azure Synapse Analytics from the keynote or been by the booth or seen a session before this one? Okay, awesome. Okay, so at a high level, Azure Synapse Analytics is the next generation of Azure SQL Data Warehouse. As you may have heard from previous sessions, it blends big data, data warehousing, and data integration into a single service for end-to-end analytics at cloud scale. So this is the next generation of the existing Azure SQL Data Warehouse product that you know and love today. Now it's Azure Synapse Analytics, and you get some awesome improvements and awesome new experiences and technologies that help you build your analytic solutions end-to-end through one experience much more easily. I'll do a quick breakdown of what goes into Azure Synapse Analytics and what benefits you have. So Azure Data Lake Storage Gen 2 as the backing store for the data that you're operating on within Synapse Analytics. That service gets you enterprise security, enterprise-grade security. It's optimized for analytics. It's a big data ready storage solution, and it's integrated with the common data model story. So we have more information we can share about that a little bit later. So from a platform perspective, Azure Synapse Analytics really brings together from the different components that you might have used previously into one experience to have a common management solution, a common management sort of uniform story there. Security, you can secure your solution in one experience with Azure Synapse Analytics rather than having to mess with sort of permissions on multiple different things, multiple different ways. Same story for monitoring. Whereas previously you might have had to go to 10 different places and sort of wire up things to really monitor and understand your solution end-to-end. Solution level monitoring is something that is coming with Synapse Analytics so that you can monitor your overall solution and drill in and find out, okay, not just what happened with my pipeline, let's say, or how can I improve my pipeline, but a certain component, I want to investigate that in particular. Well, if you develop that within Azure Synapse Analytics, you get those rich insights and development capabilities. As well as a common sense of a metastore. So Spark and SQL operating on the same data because they're both aware of the tables that were created in either of those mechanisms. Data integration is another really, really fundamental and important aspect of using Synapse Analytics. Developing any solution on Synapse Analytics or in analytics on any platform, a key part of developing such a solution is how do you perform data integration? How do you orchestrate or transform or move your data to make sure that it goes from one aspect of your solution to the next? So integrated platform and services for management, security, and all these components is very, very important, but also leveraging 90 plus connectors for where data lives, how to secure it, and where compute may live so that you can have compute be a key part of your analytics solution. As I mentioned, SQL and Spark can both operate on the same data in the lake using Synapse Analytics. That's a game changer for a lot of folks because what they're able to do is prepare or analyze using something that they're familiar with, Spark, and have that land data in a place that's ready to serve using something like SQL pools in this case, or also analyze data using T-SQL in both provisioned and on-demand fashion. So you have some files in your lake. You want to analyze those files just real quick to see what the data looks like, but you don't have to spin up a whole database or data warehouse to do so. You can use SQL on demand to do this. And also, of course, languages. Many languages are supported in Azure Synapse Analytics for the solution development. So we meet developers where they are in terms of the language that they're familiar with. If they love SQL, they get the benefit of T-SQL for on-demand purposes as well as provisioned data warehouse objects, as well as, of course, for Python folks, you have notebooks or Spark jobs or many other ways to leverage Python for your development needs. And of course, as we always mention, the studio is the center for bringing all of the solution building together into one single pane of glass. So the place where you manage, you secure, you monitor, you analyze your data, you build this whole solution is in one place called the Synapse Analytics Studio for a single great single pane of glass experience. Of course, you can use other clients as well in order to sort of like SDKs and APIs and many more to really connect as you're used to your SQL or to your Spark. But the Analytics Studio really makes this easy in one place. And all of these together really allow you to leverage multiple kinds of workloads at any scale. This idea of you can use artificial intelligence, machine learning, Internet of Things, and more, leveraging the capabilities that are part of Azure Synapse Analytics. So let me show you what this looks like within Synapse Analytics, specifically with regard to security. So this session being focusing on security in Azure Synapse Analytics. One thing that I'd like to demo is how Spark and SQL operating on the same data can leverage the fact that you're logged in as an AAD user and being an AAD aware system, and AD-less Gen 2 being AAD secured. We're able to make this a really easy data prep and data exploration and data analysis solution. So let me go ahead and show the demo here. Let's see. Okay, so let's see, where am I? So I am looking at a Synapse Analytics workspace. What I have here is, I have obviously my overview, my data section, my develop section, and my orchestrate section where I can really develop different parts of my analytics solution. So in the data section, that's where I'm really exploring the data that I've ingested. So in this case, I'm looking at a taxi cab AD-less Gen 2 account where I've landed data. And I'm looking at some taxi cab data sets that are in a Parquet file format. Now, one thing that you'll notice that's really awesome that I can do is I can look at this Parquet file, I can right-click and say New SQL Script or New Notebook. And what that allows me to do is it generates some code for me where I can read that Parquet file using T-SQL with SQL on demand right away. And what you'll notice about this code that it generated, this query, is that there's no user credentials anywhere. There's no credential object that has to be used. What it's doing is it's giving a path to the file in Data Lake Storage Gen 2. And running it, I have, I'm using this within, I'm logged in as myself in AD, and that file will be accessed as me. If I didn't have access to this file, that query would fail. If I had instead gone and said, I want to generate a notebook, I would get a very similar thing where I can see code that I would use in Spark in this case, on a Spark notebook, to look at that same file. And just as before with SQL on demand, what you'll notice in Spark here, in the Spark notebook, is that I'm looking at this Parquet file, and I'm opening it up as a data frame, and I don't have to specify any connection information, any credentials. I'm running this notebook. When I run this notebook, it'll be run interactively using my identity. So my identity will be used to see if I have access to that file, and the file will be read. Now, looking at this notebook that goes a little bit more goes beyond just reading that file as a data frame. I'm using Scala to read the yellow cab, put in the data frame, read that yellow cab data. I'm dropping some information that I don't need as part of a data prep kind of step, or a data cleansing or data prep step. In this case, as you might have seen from the previous session, I can use Dataflow for data preparation. In this case, I'm a Spark developer. I really like just using my one notebook to do all these things. So I'll go ahead and modify the data frame to drop certain information that I don't need. And then I will print the schema and basically write this data to a SQL pool. What this allows me to do is, without specifying any connection information besides just where the data is or credential information, I can also write out to a SQL pool. So just as you might have written out to a SQL data warehouse before from Spark, you might have had to specify some credential or connection information that's more than just where the data is going. Here you see that I'm just giving the landing spot for the data. And I'm able to basically specify here, here's exactly the name of the table where I want to output this data. Once this data is output, it lands in my SQL pool. So what I can see is that I'm outputting to this table called fact yellow cab. So I'm looking at these tables, and I see fact yellow cab, and look how easy it is to right-click on this, or not right-click, click on this context menu, and say I want to select the top 1,000 rows. And what I can see is where that takes me is this place where I can see the top 1,000 rows of this table And running that, I see that this data is now available in my SQL pool as sort of the structured table that I got from just simply, and it's already running this top 1,000 rows. Analyzing that data, I'm able to now analyze that data now that it's landed in my SQL pool, and I'm ready for my next phase of my solution. So throughout this entire set of stages, I didn't have to enter any information about connections. I didn't have to sort of set up any wirings up between, what kind of authentication am I using, or copy any GUIDs from left to right. All I had to do was find the file in my Data Lake Storage Gen 2 that was connected to my workspace, right-click on it, and choose what I wanted to do, analyze it in Spark or analyze it in SQL, and then I can move on from there. All right, so thank you so much. Let me get over. Cool.
Okay, Matthew, thank you.
Sure.
I'll need your...
Oh, yeah. There you go.
Okay, very good. Thank you, Matthew. Really appreciate that. Folks, I will say up front, I'm battling a bit of a cold. So again, apologies up front, but we'll get through it, I promise. Okay, so we'll jump into securing your data warehouse, the topic that we had within the topic here about talking with single sign-on and security within Azure SQL Synapse. So the prevailing philosophy and mindset in the data security space is assume breach. And assume breach is that mentality where people thought, hey, I have a firewall up. I've got this perimeter, this secure perimeter, that'll hold everything off, and I'll be just fine. Assume breach means there could be internal bad actors. People could get access to my systems. I can't just assume that having that secure perimeter is enough. So Verizon, they put out a data breach investigation report. They did the updated 2019 version of it. Some interesting stats here. So 71% of the data breaches were financially motivated, people looking for credit card information, social security numbers, or even intellectual property, trying to steal trade secrets, things like that, internal information. Of those data breaches, roughly a third were internal bad actors, so people within the company. So again, this assume breach concept, it's not going to necessarily stop an internal bad actor, right? 70%, roughly 70% were perpetrated by outsiders. The bottom line is no organization is immune to data breaches or security incidents. On the right-hand side here too, this interesting $3 trillion quote from Satya a couple years back. So $3 trillion, the yearly estimated market value destroyed by cybercrime. That was, again, a quote from Satya a couple years back. Industry experts predict that number is going to roughly double by 2021, so up to $6 trillion. So it's a big deal. It's a material impact on the bottom line. There's no doubt about it. So what's your role? Discover, protect, and detect. So discover your sensitive data, understand what it is, identify your misconfigurations, get compliant, stay compliant, and on the protect side, configure your proper access control, use data encryption where possible. Where it's not possible or feasible, use data obfuscation techniques. On the detect side, things like SQL threat detection for query injection, identify your credential usage, see where there's theft, where there's leaks, and then from an extraction standpoint, understand where people are pulling your data to and how you can secure those channels. From a compliance perspective, we've got your back. There's no doubt about it. This is the largest compliance portfolio in the industry for SQL. You'll see some familiar things on here with ISO, SOC 1.2 for your SOX compliance, HIPAA for health, FedRAMP for federal, and then a whole slew of other industry or country-specific compliance certifications. If you go to the Azure Trust Center, you can get more details on all of these. So from an enterprise standpoint, enterprise-grade security, Microsoft and Azure SQL has got the best, most robust end-to-end set of security features for you. When we talk about this defense in depth and going beyond just assume breach, we've got multiple layers now of ability to secure your data, secure your systems. So on the top with data protection, here we're talking about different levels of encryption, both in transport, also at rest with transparent data encryption, the ability to use server or user-specified managed keys, data discovery and classification, and then column-level encryption, which we are announcing here at Ignite for private preview. If you want details on that, come see me after. We'll also have further details in our Ignite announcement blog as well. Dynamic data masking, another data protection mechanism. That one we're announcing GA here at Ignite. So dynamic data masking will be GA. And then in the access control space, you've got your SQL-based permissions. This is your grants and your revokes, and then column and row level encryption, being able to secure both row and column. On the authentication side, SQL role and SQL user authentication, and then Azure Active Directory integration for both logins and security groups with an option to use multi-factor MFA authentication. On the network security side, we have SQL Firewall. That's been with the original version of SQL Data Warehouse since original GA. VNet service endpoints is also there as an option. And then you have Private Link, which we are announcing for public preview here at Ignite. And then finally, wrapping up here, with threat protection, you have SQL threat detection, SQL auditing, and the vulnerability assessment from a threat protection standpoint. So if we double click a little bit on network security, so from a network transport layer, we have network transport encryption, the TLS 1.2 protocol. So any communication that comes in and out of an Azure data center is secured with TLS 1.2 encryption. Even if you have a client tool that can disable encryption, we ignore that and we still pass encrypted packets back to clients. Azure SQL Firewall, again, the ability to whitelist IPs or a range of IPs. Once you get in and you're in through the firewall, then traffic is flowing encrypted over the internet through your public endpoint. VNet service endpoints, so traffic is restricted, the packets are uncapped and only accepted from the ACLed VNet. Traffic flows through your DNS entry point all the way into your DW instance. And then last, like I'd mentioned, Private Link being new, announced for public preview here at Ignite. So the ability to assign a private IP address within your VNet to a DW instance. Here, all of your data and your network traffic is staying on the Azure network. So we'll double click a little bit on the last two here, since these are the relatively newer pieces within the network security space. So VNet service endpoints, again, what we're talking about here is restricting access to a DW to your VNet. Here you have now separation of roles between the database admin, the person who's administering the data, and the person who's securing your network. So this is, again, a good defense in depth strategy. You have a simplified management now of your VIPs and your firewall rules, and you can uncheck this box called Allow All Azure Services, which I actually had one customer call the most evil button in all of Azure. So uncheck the Allow All Azure Services, allows you to interact with other PaaS services and still be secure from that standpoint. Limitations. So removing the SQL DW from a public IP, your DNS endpoint is still there, technically, and the ability to assign a private IP, which is a good segue into the next topic of Private Link. But those are two limitations in your VNet service endpoints capability. So let's take a look and click a little bit into how the whole VNet service endpoints kind of ties together. So from a end user standpoint here on the far left, you have access to and from the internet. This is coming into your VNet again. You have DDoS protection, firewall protection, that sort of thing, where you can secure in your front end to your VPN, or sorry, your VNet. Number two here in the middle on the bottom, this is where you're restricting all access coming in from your on-prem. This is NSGs, ASGs, UDRs, every TLA you can possibly imagine now. But anyways, we're coming in now express route, private link into our VNet. So this is high speed, highly secure access from on-prem systems into your virtual network. And then last but not least here, the third aspect is the VNet service endpoint, which is the ACK-link to your virtual network and the ability to have access across all the different Azure PaaS services, which SQL Data Warehouse is one of those. Okay, so private link, again, new for public preview. The ability to assign an IP address to your SQL DW instance, using VPN for on-prem connectivity, and then blocking the actual public endpoint from being addressable on the internet. What we have planned coming soon in this space, sovereign cloud support, IDNS, or the ability to have a named as opposed to just a specific IP address within your VNet, and then the ability, if you want to also still have a public-facing IP within your private link setup. So this slide, there's a little bit of build here. This is a good way to kind of see how things can all kind of tie up and wrap together. So I have my DW instance here on the right. Again, there's no public endpoint now. So the logical server name, the DNS endpoint that you had from before, is no longer addressable. Now I have this private IP address into my VNet, so 10.0.0.5. I can connect virtual machines to that endpoint within the VNet. I can connect via VNet peering to another VM outside of that VNet. I can use a VNet gateway and a VPN express route to get data in from on-prem and still, again, connect into that endpoint. And then I can also set up a VNet to VNet connectivity across the two VNet gateways and bring in access that way. So lots of different options depending on what your security requirements are, what your scenarios are, how you want to get data, but it all kind of comes together around that IP address for that data warehouse instance. Okay, so let's touch just briefly here on access control, just so folks understand what we have available in terms of capabilities for access control. So row-level security is available now in SQL DW. Row-level security, much like SQL Server row-level security, it gives you fine-grained access control, allows the ability to apply predicates to users and restrict the amount of rows that are returned to the client or to the user. It gives you the ability to centralize your security logic. No need to do the database views thing. We did that for years and years and years. Join a security table to a secure fact, or to secure your fact and restrict rows. But it centralizes the logic for security inside the database engine itself. And then what that also gives you then is application transparency. You don't have to worry about which tool a client's connecting from to ensure that you have proper level security being applied on your data. Then on the column level permissions side, much like you have with the grant syntax now, you can specify that down to the column level, okay? So here I have maybe a membership table. I've got some secure columns in there, perhaps social security number, and then I have some contractor that comes in, right? I've given them access to the columns that they need to do, they need to access to get their job done. If they come in by accident and run a XR, I'm covered here. I've got security in place. So they'll get this sort of error message returned to them. All right, In the data protection space, touch a little bit on some of the things that are there. So transparent data encryption. This is another one that's been with DW since day one. This is encryption of database data files, T-logs, and backups when the data is at rest on disk. We have two options here. You have service managed keys, or you can bring your own Azure Key Vault key and use that to manage transparent data encryption. Dynamic data masking, another option. Again, this obfuscates data as it's being returned to the client. The thing to keep in mind here is data is stored in clear text in the database, okay? And it's only obfuscated as it's being returned to the client, assuming that person doesn't have permissions. And then the last one here is column level encryption. Again, this is being announced for private preview here at Ignite. This allows you to encrypt a specific column of data using symmetric encryption. So column level encryption, taking a look at this one from a lifecycle standpoint. From a setup, you're creating a database master key, you're creating a certificate, you're creating a symmetric key, and that's kind of your setup side of the house. To use the column level encryption, then you're going to open the symmetric key, use the encrypt by function to encrypt the data, the decrypt by key function to decrypt the data, and then you'll close the symmetric key or just end the session to close the key at the end of that. The cleanup standpoint, I'm just showing you guys the functions here. I think once you start encrypting your data, you're certainly not going to want to drop your symmetric keys or your certificates, because then you lose access to your encrypted data. But those functions and those abilities are there. If you wanted to do a temporary sort of encryption of data, you could drop the keys and when you're done. So let's take a look at a demo. I've done more than enough talking here. Let's see what column level encryption looks like. All right. How's that, folks? Are folks able to see that? Or we need to go, we can go a little bit bigger. Okay. So I've already got a database master key here. I'm not going to recreate it, but I just want to show you the syntax that's here. So created a master key. Now I'll create the certificate with the encryption by password with this subject, and then I can specify a start and an expiry date. Okay. We have a catalog view then that you can take a look at to see your certificates. Then I'll create the symmetric key here. One thing to keep in mind, if you do accidentally delete your symmetric key, you can recreate that with the same key source, keyword, whatever you specify here, as long as that is specified again when you're creating the symmetric key, you'll be able to get back at your data. Again, another catalog view, sys symmetric keys, where you can see the symmetric keys that exist. Here I'll create a simple table and put some data in here. Nothing too exotic. Now I get into usage of the key. Here I'm going to open the key. Take a look at the catalog view. And then when I select from the table here, so we see I've got the data, but I haven't done anything with encryption yet. So what I'll do now is I'll update this null column, and I'll use the encrypt by key to encrypt the data and update this column of nulls here. All right, and then I'll select from the table, so we'll get the actual data, the encrypted data, and then I'll use the decrypt by key to actually decrypt the data as I'm returning it. So we'll see all these things side by side. So there's the original data, the decrypted data, and the encrypted data in the middle. One thing I did want to mention here, so you notice here, I've got two matching values, but the encrypted value that is actually being shown is different. Okay, so this is non-deterministic encryption. If you're going to encrypt your data, don't think that you can join on it, okay? Because it's not predictable. So there is a feature inside of SQL Server called always encrypted, which gives you an option to have deterministic encryption. We'll look to have support for that in the future. But for now, with column level encryption, it is non-deterministic encryption, okay? So that's that. One other thing I wanted to show you here. So I'm doing an explain plan here. So we'll take a look at what the actual SQL Server, SQL DW distributed query plan is. And what I wanted to call out here, so this is the all operations aspect of the plan. So we actually push the decrypt by key, the function call, down to the underlying compute nodes. So we're not collecting up all the data and then returning it to the control node and doing a mass decryption of data. So we push it down to the compute nodes. That gives us the good MPP scale out, and we run the function calls down on the compute node itself. All right, and then I'll just do some cleanup here. So that's closing the key, dropping the key, and dropping the certificate. All right. So the last one I want to talk about was dynamic data masking. So dynamic data masking is an obfuscation tool you can use to limit access to sensitive data. You've got 4 different options that you can use for data masking. You've got the default or full, which just gives you a series of X's with the data masked out. You have an email function, which gives you the first letter, and then you can kind of see how the masking rule is applied there with a .com at the end. You can specify a random integer, random range of integers. So here I'm just saying year of birth, 2001, and then I'll show you how that looks from a randomization perspective. And then a pretty famous one, the custom string, the ability to use a custom string to mask things like social security number. That's the most common use case for that. Some considerations, like I mentioned before, data is still stored in clear text in the database. So this isn't encryption. This is just obfuscating the data on return to the client. CTAS and select into adhere to the masking rules. So if you don't have proper unmask permissions, when you select the data, you're going to get masked data. You can use execute as and revert. Those are a couple of good functions that we've exposed in SQL DW to test your masking. And then to view the masked columns, we have the sys.masked_columns catalog view, where you can see how things were masked. So let's wrap up one last demo with dynamic data masking. All right. So I'm going to create this employees table. So here I have employee name, and then I'm using the masked with function default. Social security number, I'm using the partial function here, XXX, and then I'll give you the last 4, the quote-unquote last 4 of your social security number, pretty common terminology that's used. Personal email, we'll use the email function, and then year of birth, I'm just saying a random range between 2100 and 1900 for year of birth. Insert some values into this table, some of my favorite Minnesota Vikings names here, go Vikes. Any Vikings fans out there? So just names, random social security number, email, and that's their actual birth dates, by the way, if you were interested. So let's go ahead and test it out. And we see, oh, there's the actual data. It's not masked. So I'm logged in as server admin for this to run the demo right now. So I'm not going to see masked data because I have full perms to the entire database. Now, if I want to test it out, I've created this test user login. I've given him grant select or her select on the database. I've created a schema, granted control in that schema, and I'll use that a little bit later in the demo here. So now I can use this execute as function. So now I'm in the context running under the test user. And then when I come in to view the employee table, then I get the actual masked data. Okay, so social security number, last 4 numbers, first initial of the personal email, and it obfuscated everything to .com, and then a random, and it continues to be random on each select for year of birth. Now I can revert, get out of that test user context, take a look at the catalog views so I can see the masked functions that were used for each of these. And then I thought for fun, for a little bonus, let's try to steal some data. Let's figure out a way if we can come around so I've got this test user table here in a very nondescript table name here called stolen employee data that no one will ever notice. And then again, I do my execute as, and then try to actually steal the data. And then when I think I've got something that's worth it, and I take a look at it, okay, like I said, the masked data and the masking rule is applied on the select, so when I'm trying to extract the data, even though it's stored in clear text, I'm pulling it through the masking rule and inserting it into the database. So I've stolen garbage data now, okay? It's obfuscated data, okay? And then last but not least, revert to turn off the test user context. Okay, so that's that. So to wrap up, I'll bring this slide back up, or this build. So the defense in depth. The whole idea with this, the key takeaway that I want folks to have, we've got a tremendous set of rich features in the security space. Have a strategy, understand what security capabilities you can use to secure your data and ensure you're not going to be the next victim of a data breach. Okay? All right, folks, that's it. Thank you very much. Any questions? Come on up to the mic.